Hello everyone. We need to find the value of n in the given equation. Write this 9 as 3 square, 49 as 7 square and 121 as 11 square. On the right side we can see that 21, 33, 77 are multiples of these three numbers 3, 7 and 11. So write 21 as 3 into 7, 33 as 3 into 11, 77 as 11 into 7. Here send this square to outside and bring this n to inside like this 3 power n whole square. Similarly, 7 square whole power n is 7 power n whole square. 7 power n 11 power n whole square. And distribute this power n whole power n to individual numbers 3 power n into 7 power n. This will become 3 power n into 11 power n. Similarly, 11 power n into 7 power n. Here, let's consider 3 power n as x, 7 power n as y, and 11 power n as z. When we substitute these values in this equation, the above equation will become like this: x square plus y square plus z square is equal to x into y plus x into z plus z into y. Now multiply with 2 on both sides. This equation will become 2x square plus 2y square plus 2z square is equal to 2xy plus 2zx, 2xz plus 2zy. Write this 2x square as x square plus x square, 2y square as x square plus y square like this. 2x square is written as x square plus x square, and bring this 2xy from right side to left side. It will become minus 2x. Write it here. Similarly, write this 2y square as y square plus y square, and bring this 2zy to left side. It will become minus 2zy. Similarly, 2z square is equal to z square plus z square, and bring this 2xz to left side. It will become minus 2xz. Here in this equation we can see these three variables x square minus 2xy plus y square are of form a minus b whole square. So it will become x minus y whole square. Similarly, these three variables y square minus 2x 2zy plus z square are of form y minus zx whole square. And take this x square and z square minus 2xz. These three variables we can write it as z minus x whole square. For any value of a square is always positive or 0. So let's consider this statement and apply to our equation. So let x minus y is a. When it is squared, x minus y whole square. So it's always positive or 0. So the x minus y whole square is always positive or 0. Similarly, y minus z whole square is always positive or 0. Similarly, z minus x whole square is always positive or 0. Now consider one more statement. The sum of any non-negative numbers is 0 only when all of them are equal to 0. So these are non-negative numbers. X minus y whole square is a number, non-negative number. Y minus z whole square is non-negative. Similarly, z minus x is non-negative number. So the sum of these numbers is equal to 0 only when all of them is equal to 0 individually. X minus y whole square should be 0. Y minus z whole square should be 0. Z minus x whole square should be 0. Now let's take this x minus y whole square is equal to 0. We can write x minus y is equal to 0 and x is equal to y. Similarly, come here. Y minus z is equal to 0, y is equal to z. Z minus x is equal to 0, z is equal to x. Let's consider these three equations. X is equal to y is equal to z, and z is equal to x. By using these equations, by combining these equations, we can say that x is equal to y is equal to z. From x is equal to y is equal to z, we can say 3 power n is equal to 7 power n is equal to 11 power n. We are having mathematical formula when a power n is equal to p power n, the a is equal to b. So by applying this to our equation 3 power n is equal to 7 power n, 11 power n. So it should be that 3 is equal to 7 is equal to 11, which is impossible, which is incorrect. So for this equation to be true, only possibility for 3 power n equal to 7 power n is equal to 7 power n is n should be equal to 0. This equation is true only when n is equal to 0. Let's take n is equal to 0. 3 power 0, 7 power 0 is equal to 11 power 0. This 1 is equal to 1 is equal to 1. So finally the value of n is equal to 0.